Hi there, welcome to the third problem in the Problem Corner playlist. The problem that we will do today is very simple and very well known, having multiple solutions which are available. However, if you keep watching to the end of this video, we will discuss a very unique and unseen approach to this problem. This novel approach gives us elegant tools to tackle many questions, few of which we'll be seeing in the Problem Corner playlist. So the problem goes like this. A small stone is thrown from the ground with a velocity u, making an angle theta with the horizontal. When does the velocity of the stone become perpendicular to the initial velocity? What is the speed at this instant? Now, I am pretty sure you would have seen this problem. But watch till the end and we will discuss a very unique solution for this. But before that, let us take stock of the standard solutions of this problem. The first solution. This is the most common solution and you will find this in multiple books. Taking the plane of motion of the stone as the xy axis as shown, we can write the initial velocity vector as u vector is equal to u cos theta I cap plus sin theta j cap, and the acceleration vector I can write as minus g j cap. Now, the velocity vector at any later time t can be written using v is equal to u plus at in the vector form. Now if you substitute u and a here, you will get v vector is equal to u cos theta I cap plus u sin theta minus gt j cap. This is fairly standard stuff. Now we realize that when v is perpendicular to u, we must have v dot u is equal to 0. The dot product of two perpendicular vectors is 0 and therefore v dot u should be 0. Now substitute v here, u here, take the dot product, simplify this and you will get t is equal to u by g sin theta. And now if you substitute this t back into the expression of v and take the modulus for speed, we get v is equal to u cot theta. There is a fair amount of calculation here, but the method is quite straightforward. Now let's look at the second solution. This solution harnesses the fact that velocity is tangent to the path. Now as velocity is tangent to the path, we can say that at the desired instant when the velocities become perpendicular, the tangents to the path at these points must also be perpendicular. Now the slope of the initial tangent is m1 is equal to tan theta. To find the slope at the general point, we note that m2 will be dy by dx. Now I can divide by dt in the numerator and denominator and this becomes dy by dt by dx by dt, which is vy by vx. And so we can write m2 is equal to u sin theta minus gt by u cos theta, which are the values of vy and vx. Now as the tangents are perpendicular, we have m1 m2 is equal to minus 1. And therefore tan theta into u sin theta minus gt by u cos theta should be minus 1. Simplify this, you will get t is equal to u sin theta. Now you can find vx and vy and we will find the speed as v is equal to u cot theta. Again, not a very short solution, but very standard concepts are involved here. Now we get to the third solution. Now this solution is much better than the other solution in terms of calculation. Now in this, if we take x and y axis along the tangents, when the velocities have become perpendicular, the vectors u vector and v vector are along the axis and therefore there is no need to resolve them. However, we will have to resolve the acceleration g and we will get ax is equal to g sin theta and ay is equal to g cos theta. Fairly standard stuff. The acceleration has to be resolved because now it is not lying along one of the axes. Now we note that when the velocity becomes perpendicular, the x component of velocity will have vanished. So now if I use vx is equal to ux plus ax into t, the final velocity in the x direction is 0, initial velocity in the x direction was minus u, acceleration in the x direction is g sin theta, substituting we get t is equal to u by g sin theta. And in the y direction similarly we can say vy is equal to uy plus ay into t. Now vy is the speed v we want, uy is 0 because you realize that initially the velocity vector was pointing along the x direction, ay is g cos theta and the time we just found is u sin theta by g. Now if you substitute you get v is equal to u cot theta. Again, this is a much better solution as far as calculations go, but what we are about to do next will be so simple that once you see it you will start thinking like this in other situations also. So now we get to the non-standard method. What I will do is, I will denote the acceleration as g vector is equal to minus g j cap. So that whole thing minus gj cap, instead of writing a vector, I am writing as g vector. Now as the motion is uniformly accelerated, we can say that v vector will be u vector plus g vector into t. Now look at this expression carefully. This is the vector addition of two vectors u vector and g vector t to get v vector. So can we draw a vector triangle for this? Yes, we can. This is u vector at an angle theta from the horizontal. This is g vector into t, which will point vertically downward. And closing this triangle is v vector, which is perpendicular to u vector. Now look at this triangle. What is this angle? Isn't it theta? Indeed it is. I trust you can see that. Now looking at this triangle, just write sine theta. Sine theta is perpendicular by hypotenuse, so sine theta is u by gt, and therefore t is u by g sine theta. And now write tan theta, perpendicular by base, so tan theta is u by v, and therefore v is u cot theta. Do you see how simple this is? As far as I know, this is an original solution to this problem. And its simplicity is such that once you see it, you won't forget it. In the next video, we will continue this line of thinking, and as an illustration, what I will do is, I'll derive all the expressions for a standard projectile, range, height, time. We'll derive all the expressions just by using a right angle triangle. No x component, no y component, just a right angle triangle, write sine theta, cos theta, tan theta, you'll get all the answers. That video will be coming very shortly. So I hope you enjoyed this unique solution to this problem. For more such intriguing problems, keep watching the Problem Corner playlist of the Genesis YouTube channel. Serious JEE aspirants may also want to check the solutions of JEE 2020 Physics playlist. And if you like the work, like, subscribe, and share widely amongst your friends so maximum students benefit from this. Till the next problem, stay safe and stay healthy.